This is the next subject, I suppose, or the next concept we are going to learn as far as geometric applications of exponents. We're going to be giving you a formula in which the formula has exponents, and you are to calculate you're calculating measurements of some sort by using that formula, okay? We just did Pythagorean theorem. That was a squared plus b squared equals c squared. That was how to calculate the length of the missing sides of a right triangle. All right, now we're going to look at volume. All right, volume is how much matter, how much space something takes up, okay? And we're always going to be dealing with three-dimensional objects here, okay? 3D objects, because that's volume. All right, y'all have learned a cube is, because every time I asked y'all what the area of a square is, you always say length times width times height. Well, that's 3 dimensions. That's if you had a rectangular prism or a cube, you'd say length times width times height. Actually, if it's a cube, you just say length squared or side cubed rather, because you have 3 sides now, length times width times height. And if they're all the same, you could take one of those numbers and cube them. We're going to be looking at volume, all right? There's 3 shapes specifically that we're going to look at with volume. Now, what I want y'all to remember first and foremost, let's see here. When we're talking about the volume, let's take a rectangular prism. All right, let's say I have one of these guys. If we're going to calculate the volume, we know that this is 10, and this is 5, and this is 7. We're not going to say length times width times height. We're going to say the area of the base, and that we use a capital B, not a lowercase b. It's just the notation that we use, and then you multiply it times the height. So if we look at the area of the base in this question is a rectangle. You have a 5 by 10 rectangle. Well, if you take the area of the base, that is all this stuff right in here, and we stack on top of that. You know, we stack slices of that on top of each other. So you'd have a 5 by 10, and then you have another 5 by 10 on top of it. As you kept stacking, that stack would continue to grow, and you'd have the volume of the entire thing. So what we're going to do is do the area of the base, which is 5 times 10, or, you know, it's the bottom, which is the rectangular. And then you multiply it 7 times, and you're going to have the volume here. It would be 10 times 5 times 7. All right. Now, we're going to use that same logic here. Where did my things go? Where'd they go? There they are. We're going to be looking at cylinders. We're going to be looking at cones, and we're going to be looking at spheres. All right. Here's a good cylinder right here. This is what a cylinder looks like. Most kids think of Coke cans when they think of cylinders. All right, a Coke can is a very good cylinder. I also like to think of it as a 3-dimensional circle, because if you see the base, it's a circle, and it's just a bunch of circles stacked up on top of each other. Okay, this is a cylinder. Oh, AR? ER. I think that would have known that by now. Okay, so we have a cylinder. We're going to take the area of the base, and we're going to multiply it by the height. That's the same thing. The other one we're going to look at here are cones. A cone. Y'all have all seen what a cone looks like. It looks like a little something that you put ice cream into. Let's see if we have a good one of these. Cylinder. I can't find a cone here. Oh, well, I'll draw it here. It's the same thing. It's just, you know, it looks like something you put ice cream in, okay? And the last one that we have here is a sphere. Y'all have all seen a sphere before. Y'all know how to play basketball. Y'all know how to play soccer. Y'all know how to bowling. I mean, all of that are, most kids say it's three-dimensional circle. I don't really know about like that definition. A sphere is going to have it's 3 dimensions, and every side on the outside of the sphere, every point that's on the outside of the sphere is the same distance to the center as every other point on the outside. All right, we're going to be looking at the volume of all of these shapes right here. Okay, so we need to know these volumes here. We need to know these formulas here. So I'm going to take this and I'm going to move it down here in order to answer some questions. And the formula for the volume of a cylinder is pi r squared times the height. Remember, we said the area, the base, and we're going to multiply that times the height. Well, pi r squared is the area of the base. Like, the base in this case is a circle, right? So if you think back and you remember what the formula for the area of a circle is, it's pi r squared. So you're going to do pi r squared, and whatever the r is, that's the radius. It's from the center all the way out. And you're going to multiply it times the height. Another way that it could be written is capital B times H. That means the area of the base times the height. And you have to know that a cylinder, the base is a circle. All right, so how you would answer a question like this is the very first thing you're going to do So how we would answer a question is, let's say this had a radius of 4 centimeters, and we wanted to figure out the volume. First thing you're going to do is you're going to write down the formula. That's pi r squared times the height. And we also need to know the height of this. I'm just going to make an arbitrary number up here. Let's just say 10 centimeters. Okay, so we're looking at a cylinder. I'm trying to think. This would be like if you had like a cylinder-shaped object that you were using on a board game. 4 centimeters is the radius for the circle, so it's not very. We're not talking about a very big cylinder here, okay? Something that's maybe about, I don't know, less than an inch tall. 4 centimeters, 10 centimeters. We have all the information we need. We're going to say the volume is pi times r. Well, in this case, that's 4, and we're going to square it. And we're going to multiply that times the height, which is 10. So I'm going to do this as much as possible without a calculator as I can. I'm going to do pi times 4 squared, which is 16, times 10. And since now we're multiplying, you can go any which way you want to. We could do 16 times 10 times pi. That's the same thing as pi times 10 times 16. I'm just going to say this is pi times 160. Now, if it said leave your answer as the exact answer, 160 pi is your answer. Ding, 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 ding. If it says round it to the nearest tenth, or if it's multiple choice, you want to multiply pi times 160, and we're going to use 3.14 as our estimation for pi. If you use one of the graphing calculators or one of the calculators you have on your desk, the TI-83s, it's going to give you even a more specific definition. So we're going to say 160 times 3.14, and that gives us about 502.4. Now, we are going to say centimeters cubed, because we're now talking about 3 dimensions. We're talking about length, width, and height. So we are talking about 3 dimensions. We'd say centimeters cubed. That would be the volume of that cylinder. Okay? Let's look at cones. A cone is just like a cylinder in every single way, except it's just a little bit smaller. It's been, I guess, what do you call that? Convex or concave, depending on which way you're looking at it. It's the same thing as a cylinder. It's got the same base, which is a circle. It's just when you stack the circles up on top of each other, they're getting smaller and smaller every single time. So the formula for the volume of a cone is the exact same formula, except, as y'all are going to see that when we try this on a later date, if you have a cone and a cylinder that have the exact same radius, let's say, so let's say that's 4 and the height is 10, you would see that the cone is 3 times smaller than that of the cylinder, or you could say that the cylinder is 3 times bigger than that of the cone. So if we say 3 times smaller, what we mean is the volume is, the formula is the exact same, except we would divide it by 3 because it's 3 times that of the cylinder, okay? It's just pi r squared times the height, and you can either multiply it by 1/3, or it's the same thing as saying pi r squared times the height, and then at the very end you divide it by 3. Either way, you're going to get the same answer if you multiply by 1/3 or divide by 3. Don't get geeked out about this fraction. We're going to put it all in the calculator at the same time, or we can answer like this. So the volume, we're going to write the formula down. I'm going to divide by 3. I'm going to say pi r squared times the height divided by 3. My radius is 4. So I'm going to say 4, and this is a 10. Still, it's the same dimensions. It's just now we have a cone. And then we're going to multiply that by 10, and we're dividing by 3. Okay, so we're now going to have pi times 16 times 10, all divided by 3. And the volume now is going to be 16 times 10. We said it was 160, so that's pi times 160, and then all divided by 3. If you remember, when you multiply by 3 and divide by 3, it's like you're not doing a thing. So when we multiply 160 times pi, and then divide by 3, that is very close to us just not doing anything to 160. I bet you my answer is going to be close to 160. I bet you it's going to be just a little bit more. So if it said, what is your exact answer? We could leave it like this. Or you'd simplify 160 over 3. All right? Where'd it go? If we did 3.14 times 160 divided by 3, you get 167.46666. The sixes are repeating. So we said that this was 167.5. We'd say centimeters cubed. Sorry, I'm running out of room here. 167.5 centimeters cubed. All right, which is very close to 160. You know, when you multiply by pi and divide by 3, it's like you're not doing anything. All right, so it's almost like your formula is pi r squared, or it's pi r squared times the height. I'm sorry, radius squared times the height, because the pi and the divided by 3 are multiplying by 1/3. That cancels each other out. We'll look at more of those, okay? Now, the last one, sphere, that we're going to be taking a look at in this video, that's cylinder. This one is cone. Sphere. I'm going to show you exactly, I've told you why just now, like why a cylinder has the volume that it does. Like, it's the area of the base times the height. The same thing with the cone. It's the area of the base times the height, but it's going to be 1/3 of that. The formula for the volume of a sphere, it is very complex. If I try to explain it to you, it's going to involve calculus, I think, in a lot of times. You're just going to have to trust me on this one. You're just going to have to trust me that the formula for volume of sphere is 4/3 pi r cubed. All right? I have yet to find a way, and I have asked a lot of people in the academic world, like, how can I explain to my kids why the volume of a sphere is 4/3 pi r cubed? And it's too complicated. You get into calculus and that sort of thing. So the formula for the volume of a sphere, and we've all seen a sphere before. It's like a baseball, tennis ball, ping pong ball, hockey ball, or bowling ball. It's just like a ball, okay? So we're going to, let's use my spheres here. I have circles, so it's going to look something like this. And then let me use white. It's like a three-dimensional, it's going to go like this, and it's going to go around. Okay, so it's a three-dimensional. Now, let's say our radius here, from here to the outside, let's say it's 5. The first thing we're going to do is we're going to write down the formula, 4/3 pi r cubed. Make sure you don't use it at 2 right there. We're going to say the volume is 4/3. We're going to leave that till the very end. 4/3 times pi. Our radius here is 5, so we're going to say 5 to the 3rd power. And if we really think back pretty hard, hopefully y'all can remember that 5 to the 3rd power is 125. Now, at this point, you can put all of this in the calculator at the same time. 4 divided by 3 times pi times 125. 4/3, I believe, is 1 in 0.33333 repeating. So if we wanted to do 4/3 times 3.14, that's 4.186666, so it's 4.186, and then we're going to multiply that times 125. 4/3 times pi times r to the 3rd power. That gives you 523 I think it was 3. And we're going to say centimeters cubed because we're talking about 3 dimensions. And this was 5. Let's say 5 centimeters just to be a little bit more specific. Okay. The next video, I'm going to show you some examples about what we're going to do. I'm going to show you some areas some things not to do, some ways to go wrong here. So just as long as you understand that concept, for right now you have your 3-shaped cylinder, cone, and sphere, and those are the volumes those are the formulas that you need to know. Okay, pi r squared times the height, 1/3 pi r squared times the height, and then 4/3 pi r cubed. All right, good deal.